Welcome to Study Loop.
For part A of the problem, lambda naught decays into proton plus cation negative. Lambda naught has got a rest mass energy of 1115.6 mega electron volt. Proton has a rest mass energy of 938.3 mega electron volt, and cation negative has got rest mass energy of 493.7 mega electron volt. The rest mass energy before the decay is less than the total rest mass energy after the decay, so the energy cannot be conserved. Energy not conserved. Then a momentum can be conserved. The lambda and the proton each have a spin half. So this has got h cut over 2 proton. So here I will write lambda naught, here proton, and here cation. So this has got h cut over 2 and cation has got a 0 spin. So the angular momentum is conserved. Lambda has got a charge 0. Q is equal to 0 here. Proton has got a charge of positive E, and cation has got a charge of negative E. That means charge is conserved. Lambda and a proton each has baryon number of +1 and +1 here. Cation has got a 0, so we see the baryon number is conserved. Lambda and cation has got each has a strangeness of -1, and here is the -1. Proton has got a strangeness of 0. We see the strangeness is conserved. Only the energy is not conserved for part A. For part B, the omega has a rest energy of so omega has got rest energy of 1680 mega electron volt. Sigma has got rest energy of 1197.3 mega electron volt, and pion has rest energy of 135 mega electron volt. The rest energy before the decay is greater than the total rest energy after decay, so energy cannot be conserved. Momentum can be conserved. The omega and sigma each has got a spin of half. The pion has got a spin 0. So the angular momentum is conserved. Omega has a charge of a negative E. Sigma has got a charge of negative E. Pion has got a 0 charge. That means charge is conserved. Omega has a baryon number of +1. Pion has a 0. So the baryon number is conserved. Thus omega has a strangeness of -3, sigma has got -1, and this pion has strangeness 0, so strangeness is not conserved. Part C of the problem, cation and a proton can bring a kinetic energy to reaction, so energy can be conserved even though the total rest energy after the collision is greater than the total rest energy before the collision. So energy can be conserved here. Momentum can be conserved. The proton and lambda has h cut over 2 spin, and cation and pion has a 0 spin, so the angular momentum can be conserved. The cation has charge negative E, proton has got a positive E, the lambda has got a charge of 0, the pion has a charge of a positive E, so the charge is not conserved. Proton and lambda has a baryon number of a +1. Cation and pion has a baryon number of 0, so the baryon number is conserved. Cation has a strangeness of -1. The proton and pion has a strangeness of 0, and the lambda has a strangeness of -1, so the strangeness is conserved. Only charge is not conserved.